All right, let's take a look at this problem right here. We got to solve for x, and we're going to end up using a quadratic formula for this. And in addition to that, just to start us off, we do not want to be using these fractions. So we're going to get rid of that garbage. Now we can see, or maybe we can't see, that the -4 right there is actually -4 over 1. And we want to clear these denominators by forcing the denominators all to match. So the first denominator that I see here is x squared, which is really x times x. So I could say in this 4 over 1 that it's missing a x to the power of 2. So that means, of course, that it would take it and multiply it by x to the power of 2. And we know, so that we do not change the value of that term, that we need to multiply the numerator also by, in this case, x squared. This last term right here already has one of the x's that's being multiplied, so we'd have to multiply it by another x in order to make it x squared. And again, if we do that to the denominator, we need to do it to the numerator as well. Now this is what we end up with. And again, the main point here is that we can see these denominators all match as x squareds. Because now that they do, we can rewrite this without any of those x squared denominators. And we can see this is a little bit easier to look at. The next thing that we're going to want to do here is to make this a standard form quadratic. So to do that, we're going to take that 6x and subtract it from both sides. And this may do with some little rearranging after we do this. Of course, that zeroes that out, which is exactly what we want. So we get 0 equals a quadratic. And just rearranging this with the commutative property of multiplication, as long as we see this as plus a -4x squared, and then even this would be plus a -6x, we end up with -4x squared minus 6x, and then that 1 is positive. Now we'll highlight the -4 right there, and even the 1, positive 1 right there, just so we can see that we have the two coefficients, -4 for x squared and -6 for x, and then the constant positive 1. Because this assignment comes from the quadratic formula assignment, so that means we can use the quadratic formula. So I'm using these as expressions right here, but we know if we solve these two, that's our quadratic formula, then we should be able to solve for the two x values that come from this standard form quadratic equation. So all we're going to do is take these values. We can see that the a here is a -4, the b is a -6, and then the c value is this positive 1. So all I'm going to do is go in here and replace these values, b's, a's, and c's, with the corresponding a's, b's, and c's down here. Okay, so for the quadratic formula, we have this now, and we'll have to keep in mind as we look at these, we got a -6, a -6, and then also it's a -6 to the power of 2 with the negative inside of that parentheses there. So working through this quadratic formula, of course, you could just type this into the calculator and probably give you the answer. But I'm going to do this, I'll show it step by step. So first up here, all I've done is removed the negative, which is positive 6. I did 2 times -4, which is -8. And then I did -6 to the power of 2, which is 36. And 4 times -4 times 1 is -16. Now I've done this for both. Again, the only difference with the quadratic formula is one of the answers will be the negative b plus this discriminant. And then on the other side, we got the negative b minus the discriminant. So continue to work, especially within this set of this radical right here, the square root. 36 minus -16 is going to give me positive 52. And now just simplifying that square root of 52, which is 4 times 13. So the square root of 4 is going to be 2. So it's going to end up being 2 times the square root of 13. And then the last thing we see is that 6, 2, and 8, or -8, on both of these are all going to be simplifiable by 2. So we can start dividing those by 2, and here's what we get. Now these two answers down here, as far as I can see, cannot be simplifiable. So when it asks for the answer, we can just say x equals these two, And that does it for this problem. I guess the last thing I should mention here is that sometimes they'll say don't make the negative on the bottom, although I don't know that it matters for the assignment. But you can just apply this negative to the 3's up above, and it's going to be the same thing right there. Now you could say, well, it needs to apply to both the 3 and the square root of 13. So it'd be -3. This would end up being a minus. And then over here, this would be a negative, and this ends up being a plus. So it doesn't really matter. You can pretty much just apply the negative to the 3 instead and be done with it, because by switching these other two operations, you're going to end up with the same exact two values.